Velkommen til Newz TV. I dag er vi taget forbi Dells hovedkvarter på Amager, og vi er her for at tale med en af verdens førende eksperter inden for Cloud Computing, Marcel van Drunen. I har sendt os en række spørgsmål til manden, bliv hængende og hør hans svar.
Well, first of all, what is it exactly that you do at Dell?
Yeah, that's the hardest question to answer always. Now, my function is I'm the enterprise technologist for high performance computing and cloud solutions for Dell in EMEA, so for the whole of Europe and Africa also, and Middle East. If people want to have a conversation about cloud computing or high performance computing, I join these sales teams and to give some extra knowledge and extra firepower to really get to know what the customer wants, and then hand it off to one of our architects who can make the end solution. Which means that I travel a lot over Europe and talk to a lot of customers about different subjects and on the forefront of the IT industry.
Obviously, a server on the internet is nothing new, but how large must a setup be before it can be, in your opinion, classified as a cloud system? I mean, is a single powerful server, which offers, for example, a database service, is that enough?
That's a very interesting question that you ask. I would assume 2 is the minimum, because automated failover is part of one of the list of things that we think cloud computing is. But in the end, modern day computers are so heavy, so powerful, that yes, you can host a fair amount of users on just 1 or 2 servers. I think the answer here is that from the user perspective, which is the most important perspective there is, if he works on the cloud, means that he's got some sort of elasticity, which means that he can scale up and scale down his operation within with no real apparent limits. Of course, if you now work with 1 person and you go to 1,000, there is some limit to be expected. But part of the way that we look at cloud is that if you want to work with twice as many people, 5 times as much people, then you can automatically scale. So if we now have servers that have up to 1 terabyte of RAM, and if one user just uses 1 gigabyte, which for a web service or something is not that uncommon, then if you're now working with 500 people, you could expand that to double of that without the users really knowing that. So if you build a cloud application that's very limited in size per user, then yes, I think you can get away with just 2 servers, 2 sites at least, with 1 server in each site. That's the bare minimum. Also, if we look at private clouds, but then in the infrastructure as a service world, some people start with just 2 or 3 servers. I think, for instance, your colleagues running the AnandTech website, they started with 3 servers and called it their VMware cloud, which may or may not be the way that you look at it. But in a way, yeah, it's a cloud. It's completely virtualized, and it's just 3 servers.
When is a service a cloud service? I mean, for example, must it be a virtual computer, a web application, or a database where you pay depending on your usage?
There are several ways to look at it. I'll make a drawing of the most common way of classifying cloud services. You can have software as a service, platform as a service, and infrastructure as a service. Each is a different kind of thing. To make it more interesting, you can do them private. You can do them public, and you can have mixed variants where you can, for instance, burst from a private cloud into a public cloud and vice versa. The best way to explain this is to give examples of which one is which. The most well-known software as a service nowadays is Salesforce.com. Salesforce.com is a CRM software. Interesting thing is that it runs on Dell hardware, and the founder of Salesforce.com, Mark Benioff, he wrote a very nice book about cloud. It's called Behind the Cloud, and it's very well worth reading. And the foreword is made by Michael Dell. So if a Dell employee asks himself, what does management think that we go to, read that book and we know it. One of our VPs, Mr. Schuckenbroek, is a main contributor to the book also. But Salesforce.com is the proverbial example of software as a service. It's a public software as a service offering. Interesting enough, HP is moving from Siebel, which used to be their CRM, to Salesforce.com. So they might be running on Dell hardware, which is interesting. An abstraction of Salesforce.com is Force.com, which is the software that Salesforce.com is built in. So if you if like to compare, Forest.com is what you now use to have the .NET Visual Studio kind of thing, but then on the web. If you build something in Forest.com, it automatically becomes a cloud piece of software. The Microsoft equivalent is Windows Azure, by the way. Nice thing about Azure is that it is a public offering now. So Microsoft has these huge data centers, partly running on Dell hardware, where they have the Azure software stack running, and you can build your application to that, which is much similar to writing something in SQL or writing something with .NET. It's just a cloud version of .NET. But you can have a private Azure stack in the near future. So that way you can show that you can have a piece of software running privately, and if you want to have it out of your premises because you don't want to pay for power and cooling anymore, or don't want to have people running around managing all your servers, you can just put them into the cloud. What also happens, for instance, Microsoft did a test with a bank where they had some application where they did calculations with, and for 11 months of the year they didn't use it very, very hard. But 1 month per year they had to redo all these calculations to close off the year. So for 1 month they needed 100 compute power, and the rest of the year they needed only 10. So what they end up doing, scaling their system for 10 or 15 compute power. I'm just using this imaginary amount of compute power here. And when that month came, they just bursted into the Microsoft data center to do their calculations there. So that's Azure. A complete different thing is the virtualization part of town, which is where we get infrastructure as a service. For instance, if you run a couple of VMware sessions with their complete software portfolio now, you can consider that your own private cloud. So if you just have 3 servers with a piece of storage underneath, and you run virtual machines, yeah, it's a sort of a cloud thing, because the only thing the user sees is that he now has 1 machine which runs somewhere. If he needs another, you can just provision another and another and another until the administrators tell him that there's a limit somewhere. So you can make it completely transparent to the user how much resources there are. And also with this type of cloud, you can have it public too. The most proverbial example of a public virtualization cloud is Amazon EC2. And we now see also other software stacks coming online that say we are Amazon EC2 compatible or lookalike. EC2 basically means that you have a couple of virtual sessions, not running in your own data center, but running in a public data center. So the question of what is a cloud, when is it a cloud, I hope that I've given some insight to it. The main things always to look at when the cloud, it has to be elastic, it has to be meterable. I hope this still comes on camera, because self-service, automated, high available. If you have to take care of your own backup of your data, it's probably not a real cloud solution. If it's not elastic, so if you have to pre-order virtual machines or pre-order compute power, it's not considered a cloud, at least we don't. It has to be metered, it has to be pay per use, and also some sort of self-service portal. You don't have to write to your provider to give you some more resources. You just should be able to go onto a portal somewhere and be allowed to get more resources.
Okay. But so which service do you think is the toughest to set up as a cloud service? Yeah. And which is the easiest?
Which is the easiest? Yeah, that's also a good example. Well, it's not for nothing that Salesforce.com is one of the first real big cloud solutions, because looking back now, it's one of the most logical things to do in a cloud way. I really like the way that they set it up. Basically, Salesforce.com is a huge Oracle database where they built an application on top of. And besides that, there's a whole forum and a community around Salesforce.com. So it's really making use of modern media. You just log into your Salesforce experience in a way, and you can help developing that product. So I think anything that's around a database with some actions on it is very easy to build as a cloud, because you don't run into the bottleneck of the internet. If you adjust some settings in Salesforce, put some data in it, it takes you 5 or 10 seconds. It's not such a big problem. If you run real-time applications, then you have more backdraft of the internet latency. I used to think hardest things to build as a cloud should be, for instance, high performance computing. But over the last months, I've had more and more customers who wanted to build high performance computing style of solutions into a cloud. I used to think, well, in high performance computing, we really need the last 1% of performance, so we don't need any hypervisor because that takes about 2 or 3% of performance. We don't want to have all the resources moving around in any data center because that will take up clock cycles. But that's not really true. Modern day computers are so heavy that you can have 5 or 10% waste for having it in a cloud. And the big side of it is, well, as I explained with the bank using Azure in a private and public configuration and bursting, most scientists doing high performance computing, they think about half the year about what they're going to do, then they are working on their models for half a year, and then after that entire time they build their program for another half a year, and then they do some calculations. So for the rest of the time they don't need the compute power, so why buy the compute power? It's looking back at it now that it happens, it's a very obvious model where we would need high performance computing. There are some applications where it's a little bit difficult to do. For instance, if you just talk about public cloud, if you have information that cannot leave your country or cannot leave your building, then it's not possible to put it into a public cloud. You can still have it in a private cloud. So in that way, as long as you move the definition of what cloud is, then everything is suitable for a cloud like service.
Okay. But based on your own experience, what service would a company gain the most from by moving it to the cloud?
Yes, in the end, the most gain is when you achieve the 100% cloud situation. That's what we see in an increasing number of small companies. If you and me would start a company now, we'd probably have our email somewhere in a Dell solution or in a Google solution. We would do Salesforce because I'm a big fan of Salesforce. If we would need a small application of our own company, we'd probably build it in Azure because, well, that's a very easy thing to develop stuff in. So we will not need a server anymore, which gives us a couple of things. We don't need a server room. We don't need power and cooling for a server room. The sad thing is we don't have as much as a good relationship to our Dell salespeople then, because we don't buy any servers from them. But that's the biggest gain. So you also don't have to have these people running around making backups, building operating systems, patching, and that sort of thing. Which will not mean that we will make people jobless, but it will just mean that the IT people of the future will have a much more interesting job. They have to integrate all the different cloud offerings and build their own applications, make sure that the data is good. So I think if you really achieve the 100% cloud solution, that's the most profit there is. And the other quick gains are, well, again, like Salesforce.com. It's also not by accident that this is the first thing really picking up in cloud computing, because it used to be very difficult to run a piece of software like Siebel. There are constantly new versions of it, patches, and you have to have these databases that had to be tuned, had to be backed up. Now with cloud computing, you just, if you have 50 people now and you hire 50 more, you just buy 50 extra licenses of Salesforce instead of having to build your own infrastructure and make it larger to fit all these 15 people in.
Now, with services such as gaming moving to cloud, like OnLive, a service that was previously thought that unheard of as a cloud service, what services do you see as a cloud service that aren't technically feasible? Do you see any limit for what could be a cloud service?
Yeah. I think we talked about this with one of the earlier questions. We used to think that a lot of things were not suitable for cloud, like high performance computing and also highly graphical solutions. In the early days of virtualization, for instance, having a VMware session with a lot of sound in it and a lot of graphics in it was really out of the question. It's still difficult. You still have to have a fairly good network in order to have the sound quality good over the line. But we're starting to see technologies like Microsoft Remote FX and similar kind of solutions, where having a virtual session with a lot of graphical information is really in reach. So currently, having been proven wrong about a couple of things that I said of that will never move into the cloud, I think I dare say now that in the next decade, I think about 95% of computing will start to move into the cloud. Take my word for it. We'll talk again in 2020, right?
Okay, I'm looking forward to that. But with so many servers making up a cloud system, there's an increased risk of bit errors. Are these problems that are given special consideration, or do the normal error correction in the servers handle these problems?
Yeah, as far as I'm concerned, yes, the normal error correction code in a service will take care of that. Bit errors were something that we have always had to hedge against. So that's why every database has got its own consistency checking. Every communication has got things to make error correction code, like TCP has got its own inbuilt checking whether a packet did arrive intact or not. So I don't think that this is a real problem, because cloud computing is basically not totally different from what we were always doing. For instance, when I started to work for American companies, we had a trading site called Saba, which we called a hosted application somewhere. Now we call Saba a cloud-based piece of software, but it used to be just application hosting. So it wasn't a problem then when we still call it application hosting, and it's not a real problem now. Where bit errors are really looked at are in the banking, in the financial systems, because a bit error there could mean you or me being a billionaire or owing $1 billion to somebody. But that's also taken care of in normal hardware correction code and in normal software procedures.
So personal information about people, especially in regards to local authorities and privacy laws, could be a showstopper for people using the cloud services. But does a technical solution exist that tackles this problem? For example, hardware encrypting the data, ensuring that not even the provider is able to access it.
Yeah, well, this is the biggest discussion around cloud computing at this moment, for very obvious reasons, because we all have seen these big scandals about data being lost and very sensitive data coming onto the market. We all know WikiLeaks. Not that WikiLeaks had anything to do with cloud computing, but it's there's a lot of focus on people's privacy, and there's a lot of focus on data safety, which should be there. There's also a debate in political circumstances, like on the country level and on the also European level. Our dear Dutch commissioner to the EU, Nelly Kroes, she's taking the initiative to guide the legislature around cloud computing, and she's now consulting the different players in the field, like all the hardware vendors and the cloud vendors, all the government organizations that might want to use cloud computing. What I think it will come down to is a principal discussion about which data can leave the country or not, and even if it's encrypted, it still leaves the country physically. So if a piece of data is Dutch only or Danish only, it should stay within Denmark or within Holland, even though it is encrypted, because we cannot guarantee that somebody will not crack a 256-bit code. It's very unlikely, but it might happen. So what I think that will be the result is that there will be some kind of Schengen treaty, but then the electronic version. So like every citizen of a Schengen country can move to another Schengen country without really being checked at the border. If your passport is valid in one Schengen country, it's valid everywhere. Everywhere in Schengen. I think we will get a sort of European electronic community, where data that's stored at one place in that community, it can also be stored in another place in that community. The good thing about that is that cloud computing really is starting to make sense if it's on a big scale, if there's economy of scale, and if you can choose where you place your data center. So for instance, it might not be very wise to put a big data center in the middle of Spain. It might be more wise to put it in Iceland, and maybe let them earn some money with that so they can pay us back. Because power and cooling obviously in Iceland is much more easy than in Spain. So if Spain and Iceland would be part of the same electronic community, then the Spanish data could be stored in Iceland without any laws being broken. So yes, there are some electronic solutions, and I think the encryption of data will remain very important. And at the same time that the encryption algorithms start to be more difficult and difficult to crack, the compute power that we can use to crack them also increases. So this is a sort of arms race that will always be there. But for instance, going back to Salesforce for the 4th time now in this interview, Dell stores the entire customer database in salesforce.com. HP is going to do just the same. Salesforce has got a lot of data centers, but not in each and every country of the European Union. So if you talk about storing information, very sensitive information somewhere, well, Dell does it already, and we consider this completely normal. So I think in the end we will get used to storing things in the cloud. We have to be very aware what is sensitive data and what not. If it's really sensitive, think again, where are you going to store it? Are you going to put it into a cloud or on your personal USB stick that you're going to use, that you're going to lose on the train?
Mm-hmm. Now both NVIDIA and ARM are planning to enter the server market, focusing on power efficient processors. Now, are we going to see more cloud systems that are based on these kind of processors in the future, aiming for a better power performance ratio?
Yes, that's an interesting question from a hardware point of view. If you look at these small CPUs with small power usage, they also don't provide as much compute power as a big CPU, which will use more power. So I think in the end the equation is the same between the NVIDIA and the VIA and the Intel Atom kind of CPUs and the big Xeons and AMD CPUs. They have more power usage, but they also have more oomph when doing computing. What we do see is that some server providers or cloud providers, they provide a lot of very small servers to people that really insist on having their own server. One of the things in cloud computing that we did not really put on the list is what we call multi-tenancy. Multi-tenancy, which means that several users or several companies can work on the same piece of hardware without that being a problem. Some customers really insist that they want to have a typical server, even though they don't use it a lot. And I think the market there is for the NVIDIA and VIA and the Atom kind of chips. So you can just put a lot of real physical servers into a data center and just give out one server to each of the customers. I think on the other end of the spectrum, if you see where Intel and AMD are going, our new servers will have 60 or 80 or over 100 CPU cores. Will have 2 or 3 terabytes. If you just put 5,000 users on it, you're just as power efficient per user as if you're using one of these small CPUs. It will be matching, and that will basically mean that I will still have a job in 9 years doing this kind of scaling.
But do you see a future for distributed cloud systems? In companies, hundreds of thousands of clients are idle most of the time, so that leaves a massive resources that are unused.
Yes. I see a lot of people trying this or thinking about this. My other function beside clouds is doing high performance computing, and a lot of universities, they marvel at all these workstations that they have with secretaries and desktops, and they want to use them for what they call grid computing. But there's a couple of things about that. One thing is that our desktop built systems, they are not built for 24/7 usage, and certainly not to be running for 100% of CPU all of the time. And the other thing is, I talked about this with our power and cooling experts, and they said, well, you can do that, but it messes up your entire governing of your air conditioning in your in your office, because if those 1,000 workstations, if they all are running at night, doing some very heavy calculations, they all start to dissipate, well, 400 watts, 500 watts. If you look at the power supply of a workstation, if it's 400 watt or 500 watts, that's because it will eventually be capable of dissipating that amount of heat into the atmosphere in your office. So, and it's not very efficient. Also, our servers that are built into the data centers, they are built for very efficient computing, and you can tailor them to the needs of your compute power that you need. A desktop system, it normally in a day just has to run Word and Excel and that kind of things. It's not geared toward high performance computing or cloud computing. So for those two reasons, the systems are not built for 24/7 usage, and it messes up your air conditioning profile. I think people should not be doing that.
Okay. But do you see cloud services one day reducing most computers to thin clients?
Yeah, that's the other side of it. Coming back on my previous question, I think if everything moves into the cloud, then you don't need any compute power on your desktop anymore, because it all happens in the cloud, and your desktop is more like a thing that captures your keyboard and mouse input, and I'll show you a display. So there will be a very minimal amount of compute power in your desktop. So there's no way that you can offload all your cloud computing onto your desktop then.
Okay. But designing a large cloud system, what is the most important aspect to focus on? Is it network, is it storage, is it servers? And where is it most likely that you will experience a bottleneck in a network system?
Yeah, that's a question with a lot of angles to it. What I think is that the most difficult thing nowadays, it's all in the hands of the software builders. The hardware is very capable. If you pay enough money, you can have a huge amount of compute power, a huge amount of memory, a huge amount of storage. Networking is a bit of a problem. Access to your internet is a bit of a problem, although that comes less and less. I just learned that in Holland we can get a internet access for just 50 euros, 100 megabit full duplex. So that's a huge amount of internet bandwidth. So most of the bottlenecks in pure physical things are getting away, or you can just throw money at them and they go away. But same as for cloud computing and high performance computing, the way you build your application has more impact on what you do than anything else. If you just make your application 50% more efficient, that's the equivalent of putting in 50% more hardware, and there's more to gain in software building than in hardware building. But as far as bottlenecks go, I think most of it is solved nowadays. It's every time and again that we build a new cloud service, it's mixing and matching, it's looking at the profile of what that particular software is doing. It's also very normal now for a cloud provider to have different hardware setups for different functions that they do. So what you see, for instance, for the social networking people, every time that they add a certain function, they will start to look at what specific software and what specific server they will need to host that typical functionality on.
Okay, but what is the typical savings in hardware percentage-wise for a company choosing to use cloud services?
Yes, well, of course, if you go to a 100% cloud solution, then you save 100% of your data, of your hardware costs, because you will not have a server anymore. We see that in about 10% of the small and medium businesses now, they don't have any server room anymore to do everything in the cloud. So their hardware savings as far as data centers is concerned are 100%. They don't buy any servers anymore. In other areas, well, if you look at infrastructure as a service, most companies virtualize in a 5-to-1 fashion. So they used to have 5 old servers, and they now have one one physical server hosting their virtual servers. What we see is that some companies stop halfway through a virtualization project. So they start with the very simple things, virtualize that, web servers, that kind of things, and then when it comes to the big exchange servers and the big database servers, they kind of stop halfway, sometimes because the software vendor didn't certify their software running in a virtualized environment. So very high percentages of savings can be achieved. but not all companies really succeed in achieving this kind of savings. But I think average will be about 30% at least.
Okay. Now, which high availability precautions are typically made in regards to hardware to ensure the safety for a service? And what would you recommend that a customer demand from a cloud service provider?
That's two questions for the price of one. What the typical things are being done? Well, if you look at Salesforce.com, it's a completely it's the biggest Oracle database in the world. So what do they do for high availability precautions? Well, it's the same thing that Oracle has always been doing. Oracle RAC and Oracle offline backupping, log shipping, that sort of thing. So it depends on what you're doing. If you're doing a database kind of thing, you will do the same database kind of safety measures. The big advantage of cloud is there. If you have 100 companies having their own databases and servers, there's 100 guys that have to do the backups and have to do the patching and that sort of thing. If you then make it into one big cloud entity, instead of all these 100 backups, you can do one big backup session. So if out of those 100 guys you just hire the 3 best of them, they can do 100 backups instead of each doing one. And that's the big advantage. And also if you do a patch to the software, you patch 100 companies at the same time, and not 100 people have to apply the same patch with 100 times the error that they can make. More in the infrastructure as a service world, it's basically the same story. When we started doing virtualization it started majorly about 5 or 6 years ago, it was still the traditional backup methods that we could use, and we are most of the time still using the same traditional backup things. But what we see now is that backupping in a virtualized environment is more moving towards the storage, building their own offline backup. Yeah, the second part of the question was, what should you demand from your cloud service provider? Well, as Mr. Benioff also says in his brilliant book about cloud computing, you can always ask from your cloud service provider for an audit. If it's a real serious cloud provider, he will have all these measurements taking what his availability is, what his performance is, if he's ever lost data, what is he doing to protect your data, and he can show you what he's doing and showing you the audit. If you're a real big customer, you can also visit his data centers. When Dell moved to Salesforce.com, I cannot imagine that Michael Dell did not physically inspect the data centers himself, just to be seeing what Salesforce is doing. And I think if you're a big cloud customer, you can do that. For the smaller companies, I don't think every single small company will go to Salesforce or to Microsoft and go into their data center or to Amazon and do a physical inspection. But I think you should really ask your cloud provider, what are you doing to protect my data? Just give me a yearly or a quarterly overview of what has happened and how safe am I.
Now, besides Dell, there are a lot of other players in the market that are selling cloud systems. Is there any kind of standard being made for these systems, ensuring that customers can easily compare them and maybe migrate from one system to another as easy as possible?
That's a good question with a lot of answers possible to that question. We can tackle it maybe on the different fronts of cloud computing. What we see in the infrastructure as a service world, or maybe you can call it the advanced virtualization world, we will see some sort of standardization. So the format that you can use for a VMware virtual machine will be or already is the same as you use for KVM or for any of the others. We now see various cloud stacks already proclaiming that they are compatible with EC2, meaning that Amazon EC2 will be the de facto standard for cloud computing in the infrastructure as a service world. On the PaaS and SaaS world, it's a completely different kind of story. But the thing to remember here is that a SaaS offering is not in its essence different than what we used to do in the normal software world, but then it's now on the internet. So Salesforce.com is in functionality very similar to Siebel, where Siebel is the on-premise version of the software and Salesforce.com is the cloud version. So is there a standard that you can choose from, or moving from one cloud provider to another one will be the same thing as moving from Siebel to PeopleSoft or something. It's two pieces of software doing the same things, but with a different kind of database. So there will be all kind of consultancy firms being able to migrate your Siebel data to Salesforce, migrate Salesforce to PeopleSoft. If you now buy Microsoft PeopleSoft and you're not happy with them again, you have to migrate somewhere, and well, that's going to be a project of a couple of months or years maybe. So one of the things that we see now developing in the cloud is something also Dell is doing. We bought a company called Boomi, I think half a year ago. The thing that Boomi does is they can do coupling of databases in the cloud, or migration of data in the cloud. So if you or from the cloud to your on-premise data center. So if you have on your VMware landscape here, if you have your own HR system running here, and you have your Salesforce.com in the cloud, then sometimes there has to be data moving from one solution to the other one. Well, that's the thing that Dell can now do with the Boomi solution, and there are more solutions like that. So is that a typical problem of cloud computing? No, I think it's the same issue that we always have had with migrating from one software vendor to another. But now we migrate from one cloud vendor to another cloud vendor.